This one wire is why your air conditioner turns on. It runs from your thermostat, and it is labeled Y. Follow it. It leaves the thermostat, travels down to the outdoor unit, and lands on a coil. The coil pulls in, the compressor kicks on, and cold air starts flowing. One thin wire, carrying a tiny signal, commands a machine pulling thousands of watts. That is the whole trick of an HVAC diagram. And by the end of this video, you will know how to read an HVAC wiring diagram, line by line, letter by letter. R, C, V, U, G. The transformer, the contactor, the compressor. Let's start with the thing that confuses everyone. Here is why an HVAC print looks scary. There are actually two different circuits drawn on the same page. The first is the line voltage side. That is the muscle, 240 volts, or sometimes 120, feeding the compressor, the condenser fan, and the blower motor. Big wires, big current, real danger. The second is the low voltage side. That is the brain, a quiet 24-volt control circuit. This is the thermostat side. It carries almost no power, just signals. Every wire on the diagram belongs to one world or the other. Learn to glance at a wire and sort it. Line voltage or 24-volt control. The moment you can do that, the page stops being a wall of spaghetti. So how does one become the other? Quick note before we dig in. Everything I draw in this video is free to open in your browser at circuitdiagrammaker.app. No install, no sign up. The link is in the description. Open the editor and follow along. Right, back to the wiring. The bridge between those two worlds is the transformer. It is a small block, often bolted inside the air handler or furnace. On the diagram, it is drawn as two coils side by side. High voltage goes into the primary side, and 24 volts comes out of the secondary side. That is it. The transformer is the little machine that makes the control voltage. Two wires leave that 24-volt secondary. One is labeled R. The other is labeled C. Hold on to those two letters because everything the thermostat does is measured against them. Now, the part everyone actually wants, the thermostat letters. Look at the terminal block behind any thermostat and you will see a row of screws, each with a letter. They are not random. Each one is a wire with a job. R is power. That is the 24 volts straight from the transformer. Think of R as always hot, waiting. C is the common. It is the return path back to the transformer, the other side of the 24 volts. For decades, dumb thermostats did not even need it. Then the calls. W calls for heat. Y calls for cooling. That is the compressor wire, the one we traced at the start. G calls for the fan, the blower. And on bigger systems, you will see RC and RH, separate power terminals. One for cooling, one for heating. So what about that C wire? A modern smart thermostat needs constant power to run its screen and its Wi-Fi. R alone cannot do that without a return. So the C wire, the common, is what gives a smart thermostat a steady supply. That is why no C wire is the #1 smart thermostat headache. Let's trace one full cooling call, start to finish. You set the thermostat to cool. The room warms up past your set point. Inside the thermostat, a switch closes, it connects R to Y. Now that 24-volt power is on the Y wire. Y runs outside to the condenser unit and lands on the contactor. And here is the key idea of the entire system. The contactor is just a big relay. A relay is a switch that electricity flips instead of your finger. The 24 volts on Y energizes the contactor's coil. That coil becomes a magnet. The magnet yanks a set of heavy contacts closed. And those contacts connect the full 240 volts to the compressor and the condenser fan. That is the sentence to remember. Low voltage controls high voltage. A tiny 24-volt signal, safe enough to run behind your wall, throws a switch that commands a compressor. If you have seen my video on wiring a relay, an HVAC contactor is the exact same idea, just built heavier. Let's make that concrete, live in the browser. This is the free editor at circuitdiagrammaker.app. I'm going to build the same control logic from scratch. A power source. A switch, think of it as the thermostat. And a load, think of it as the compressor. Then a ground to complete the loop. I search for each part, click to drop it on the canvas, and the symbol lands ready to wire. Source, switch, load, return. Watch the chain build up, one piece at a time. Now I connect them. I pick up the wire tool and click pin to pin, source to switch, switch to load, load back to ground. Every line I draw is a real electrical connection the simulator understands, not just a picture. This is the same source, switch, load pattern hiding inside every HVAC control circuit. But here's the part one love, it actually simulates. This template is a direct online motor starter. In plain terms, that is a contactor switching a motor, the exact relay logic an HVAC contactor uses on your compressor. A coil pulls in, and the motor gets its power. I hit Simulate, choose DC operating point, and run the analysis. The built-in solver reads the whole circuit and overlays the real voltages and currents straight onto the diagram. The live path lights up, so you can trace exactly where the power flows. This is the fastest way I know to understand a control circuit. You are not staring at a still picture. You are watching the electricity move. Change a part, run it again, and the numbers follow. It is a sandbox with real physics behind it. One more thing worth knowing, the symbols. HVAC prints reuse the same handful of shapes. The contactor, the run capacitor, drawn as two lines. The compressor, the fan motor, a circle with an M. The limit switch, and the transformer, those two coils. Learn 6 shapes, and most of the page reads itself. You will also meet 2 drawing styles. A ladder schematic stacks the circuit like rungs, showing how it works. A connection diagram shows where each wire physically lands. Same circuit, 2 views. The symbol library and the diagram collection are both free to browse. Open a real diagram and trace the loops yourself. So here is the whole diagram, one more time. 2 worlds, line voltage for the muscle, 24 volts for the brain. A transformer bridges them. R is power. C is the common return. W, Y, and G are the calls. Heat, cool, fan. A cooling call sends 24 volts down the Y wire to the contactor. And the contactor, a heavy relay, hands the compressor its 240 volts. Low voltage controls high voltage. Want it to really stick? Open the free editor, build the control loop, and run the simulation until every wire makes sense. The link is in the description. No install, no credit card. Subscribe for a new wiring diagram explained every week. See you in the next one.